Hello students, as we discussed about chemical properties of haloarenes in the previous video, that is nucleophilic substitution reaction. Now let us discuss electrophilic substitution reaction in this video. As we have classified the reactions of haloarenes into three types, that is nucleophilic substitution, electrophilic substitution and the reaction with metals. So, in the first we have finished, that is the nucleophilic substitution. The second one is electrophilic substitution. So, in this video we are going to discuss what is electrophilic substitution reaction. As the word electro means electron and phile means loving, that means the species which are electron deficient, actually they are called as electrophiles. Electrophiles are electron deficient, means they are usually positively charged. So let us discuss electrophilic substitution reaction, in which we are discussing first how the attacks takes place. Electrophilic substitution, last year we discussed about its mechanism. Just recall this mechanism. Here the electrophile, which is represented as E positive, that is electrophile, which is called as electron deficient species. It attack on the benzene ring. So it forms an intermediate, which is shown here, and which undergoes resonance, and with the removal of that proton, that is this H, it gives rise to the product. So, in the product you can find that E, the electron file, that is electrophile, is get binded at ortho position. You can find here E is at ortho position. Now why it happens? Why it get binded on the ortho position or it get binded on the para position? Because halogen group is ortho-para directing group. As we discussed last year, there are two types of directing groups, ortho-para directing group and meta-directing group. From this, halogen group is ortho-para directing group. That means whatever the product is formed during the electrophilic substitution, either the substitution takes place at ortho position, as here you can see the substitution is taking place at ortho position, or we get the product in which substitution is taking place at para position. So why it is ortho-para directing group? It can be better explained through resonance. Thus, the ortho and para directing effect of halogen atom can be better understood if we consider the resonating structures of haloarenes. As here, X represent halogen group. Let if it is chloro, then it is called as chlorobenzene. So these are the resonating structure as we have discussed in the previous year. These are the resonating structure, that is second structure, third structure and fourth structure. When you observe these structures, in these structures you can find that there is a negative charge. Here there is a negative charge, that is ortho position. Here there is a negative charge, that is para position, and here there is a negative charge, that is also at para position. So that means due to resonance, we can find that there is a more electron density, or we can say relatively high density, electron density at ortho and para position. We can see this here at ortho position and para position, relatively in compared to other position, they have more electron density. Because of this reason, as electrophiles are electron loving group, therefore these attacks on this region where there is a more electron density. So whenever the electrophile reaches or approaches, it attacks on the ortho position instead of meta, because in meta position, in compared to ortho and para, In meta position, the electron density is lower because there is no negative charge in the meta position. When you observe here, that is the meta position. There is no electron density greater here because at ortho and para position, the electron density is higher. Therefore, whenever the electrophile approaches, that is E positive, which is electron loving group, it attacks only on that part where the electron density is greater. It is either on the ortho position or on the para position. That's why we can say that the electrophilic substitution takes place at ortho and para position. Because of this reason only, the chloro group is called as ortho-para directing group. Thus, whatever product we are getting during the electrophilic substitution reaction of chlorobenzene will get the substitution at ortho and para position. Electrophiles can be of following types. If electrophile is chloronium ion, that is this, then this electrophilic substitution is called as chlorination. If the electrophile is nitronium ion, that is NO2 plus, then the electrophilic substitution reaction is called as nitration. And if the electrophile is SO3H, that is sulfonic acid group as shown here, then the electrophilic substitution is called as sulfonation. And if the electrophile is the alkyl group, which is represented here CH3, if it is an alkyl group, then the electrophilic substitution is called as alkylation. And if the electrophile is a acetyl group, that is CH3CO, then the substitution is called as acylation. So you can see that the type of electrophilic substitution reaction here are chlorination, nitration, sulfonation, alkylation and acylation. Why it is called as chlorination? Because the electrophile here is the chloronium ion. Why it is called as nitration? Because the electrophile here is the nitronium ion, that is NO2 plus. For sulfonation, SO3H, alkylation, R group, or we can say CH3, acylation, COCH3, or we can say COR. So we can say that electrophilic substitution reaction which we need to discuss are chlorination, nitration, sulfonation, alkylation and acylation. Let us discuss these in detail one by one. First one, halogenation. I told you chlorination. When particularly we are saying that for chlorine, then we called it as chlorination, or in general we can use the word halogenation. This reaction takes place by reacting haloarenes with halogens in the presence of ferric salt, which act as a catalyst. Here anhydrous FeCl3 is used as a catalyst. So when the reaction takes place, two products are obtained, that is, one product is major, the other one is minor. The one product which is that 1,4-dichlorobenzene, the other one is 1,2-dichlorobenzene. Here when you observe that the substitution is taking place at ortho position, you can see here there is an ortho position. This is the ortho position. Substitution is taking place at ortho position and the substitution is taking place at para position. Therefore, as we have discussed, Cl is an ortho-para directing group. That means the electrophile here, that is Cl plus, is attacking on the ortho position, that is here It is attacking on the ortho position and on the para position. Therefore, we got the two products here. That is, one is 1,4-dichlorobenzene. The other one is 1,2-dichlorobenzene. So, thus two products are obtained. Next reaction, nitration. Nitration is carried by heating haloarenes with concentrated HNO3 in the presence of concentrated H2SO4. So, at the time, two products are obtained, which are 1-chloro-2-nitrobenzene and the other one is 1-chloro-4-nitrobenzene. Look at the structure once again. How the name comes here. 1-chloro, the chloro is on the first carbon and nitro group is on the second carbon. Therefore, 1-chloro-2-nitrobenzene. Second structure, Cl is on the first carbon. Alphabetic order, C comes first. Therefore, we are representing first number for Cl and NO2 is on the fourth carbon. So, we can say 1-chloro-4-nitrobenzene. So, here two products are obtained. One product in this, the nitro group is at ortho position and in the second product, the nitro group is at the para position. Therefore, we can say that the electrophile, that is NO2 plus, is attacking on the ortho position and also on the para position. So, because of this, the two products are formed here, that is 1-chloro-2-nitrobenzene. The other one is 1-chloro-4-nitrobenzene. Now, let us discuss the next reaction, sulfonation. It is carried out by heating the haloarene with concentrated H2SO4. At the time, we can find that two products are obtained, that is 2-chloro-benzene sulfonic acid, 4-chloro-benzene sulfonic acid, because here SO3H is a principal functional group. At the time, we have to use it as a functional group. So, the name here chloro comes as a prefix. So, the name comes here 2-chlorobenzene sulfonic acid. The second one is 4-chloro, that is chloro is on the fourth position. Therefore, 4-chlorobenzene sulfonic acid. As here the two products are formed, here the substitution is taking place at ortho position and para position because Cl is an ortho-para directing group. Thus, the two product which is obtained are at one is at ortho product, the other one is para product. Now, let us discuss the other reaction, that is a name reaction which is called as Friedel-Crafts alkylation reaction. The other one is Friedel-Crafts acylation reaction. This reaction is carried out by treating the haloarene with alkyl chloride. Let us discuss the first case for with alkyl chloride in the presence of anhydrous AlCl3, which act as a catalyst here. It results in the formation of two products. One is at ortho position, the other one is at para position. Substitution is taking place at para position. So, we can say that the two products which is formed here are due to the substitution of the alkyl group here. You can see the CH3 group is actually substituted here. So, when the CH3 group gets substituted at ortho position, that is this position, you can find CH3 group is at this position. So, this is called as product 1-chloro-2-methylbenzene. Look at the structure here. Why it is 1-chloro? Because here Cl and CH3, that is chloro group and methyl group, both are substitute. But alphabetic order, Cl, that is C comes first. Therefore, you have to give number 1 to this position and 2 for the second position, that is for CH3. So the name will comes like this. IUPAC name 1 chloro 2 methyl benzene. The second product 1 chloro 4 methyl benzene, because when you see that the methyl group is at the fourth carbon, when you count it from here 1 2 3 4, it is on the fourth carbon, therefore it is called as 1 chloro 4 methyl benzene. So in this reaction also substitution is taking place at ortho and para position. From this the major product is this. Similarly, when the haloarene is treated with the acyl chloride, that is CH3COCl is called as acyl chloride, in the presence of anhydrous AlCl3, two products are formed. That is, one is 2-chloroacetophenone, the other one is 4-chloroacetophenone. Here acetophenone, because ketonic group is a functional group, therefore this part is called as acetophenone. This part is called as acetophenone, that is C6H5COCH3 is called as acetophenone. C6H5, that is the benzene ring. C6H5COCH3 is called as acetophenone, and the chloro is substituted at the second position. So we can say that the name comes like this, 2-chloroacetophenone. The other one is 4-chloroacetophenone. So here the electrophilic substitution taking place at the ortho position. Therefore, one product will be formed like this, and the substitution is taking place at para position. Therefore, this product is obtained. So this reaction is called a Friedel-Crafts acylation reaction. So these two are the named reaction. So you need to write this equation in the list of named reaction. As I told, whatever name reactions are there, write it in 1 page or 2 page, list it out so that it will be better to learn easily.